So, what I'd like to present today is my attempt of a framework on motion sickness that I call the VR comfort stack. Where did this whole thing come from? I was crazy enough to challenge myself to give a course on cybersickness at SIGGRAPH, which is a very diverse audience. You have the researchers, the theorists, the computer sciences, the people who build the hardware, who build the software. You have a lot of gamers. And I was trying to figure out how do I convey these ideas, the different frameworks and mitigation methods, so it's not just a list, but really more like a thing you can actually use and make sense of. And this is how the whole thing started, basically. I'll go into this in detail. So the main idea is really that, as you know, cybersickness is not a single problem. It's really a system of interacting layers, and I'd like to visualize and talk about these layers. So the goal in this talk is really to move from these isolated factors into more structured system level reasoning. So we all know that cybersickness is still hard, even though we know a lot of these factors already. Here's just some of these challenges that you all know. It's highly individualized, context dependent, doesn't always generalize, and so on. So the main idea is really to think more of it as a system of different layers and seeing like who's responsible for what layer, who can actually fix something, what could you do? So I'd like to take you on this metaphorical journey of climbing up what I call the VR comfort stack. So from this metaphorical swamp of bad user experience design where people drop out because they get sick, frustrated, disoriented, and so on, to the summit of good user experience, basically. And the main idea is that really to truly tackle cybersickness, we must really go beyond seeing it as a simple sensory conflict. I think you're all on board of this, of course. And really understand it more as a multi-layer system-level phenomenon and a really systemic prediction error problem across the different layers that I'll present in a moment. And I hope to convince you that if you're not already, that the cause and mitigations really operate at different levels. So they interact and constrain each other. There's a lot of trade-offs that emerge across these different layers. So let's go get started. So I'll quickly give you the big picture and then go into each detail. So we start with the set and setting, the basics, task context, postural affordance, and so on, technical aspect, and so on, more about the actual world, interaction design, and so on, then go into locomotion navigation, and the top is really the user and the strategies. And the unifying principle is what we call predictive fidelity, which is really, okay, how well does the world match or not match our fundamental inherent prediction mechanism, and splitting it up into the different layers. So each of these layers has distinct mechanisms, different actors, and different trade-offs. They're highly interdependent. And the goal here is really to introduce this idea, open up the conversation, hopefully start interesting collaborations, discussion, and so on. It's not meant to be exhaustive or replace any other frameworks. This is basically just a draft. And at the same time, we have this pyramid, but we also have the different agents. Like at the bottom layer, it's really the provider, facilitator, the user that has the most agency. And then we have what I sometimes call the inverted pyramid. So the user has a lot of agency here, not so much here. So this is basically where the manufacturers come in and so on, and also the developers and content creators. They have a lot more agency on that side. And researchers are a little bit specific because they have an influence on all these different aspects. So, layer one, that's really the foundation, the set and setting. This is really the user's mindset and the physical, social, and task environment. So, just to give some examples here, it's really about the internal state as one of the primary predictors. So, one user literally mentioned, if I'm tired, I'm more likely to get sick. If I'm stressed, not feeling well physically, I'm more likely to get sick. So, it's really this internal aspect of general well-being, mindset, health, and all these different factors that you know about. But it's also the experience and the susceptibility, the history, habituation that can really affect this layer. So you kind of retweak yourself. The setting, the room, the task, all these aspects really have a huge influence, and we've heard a lot of talks about these aspects. But there's also things like postural affordance, like does it really support or challenge the user's balance? So that's the idea of this first layer here. So, and there it's really about controlling whatever you can control, right? So it's really about preparation, awareness, taking responsibility, and really curating a safe and comfortable space. And for the users, really to check in with yourself, stay healthy, and so on. And there's lots of examples that show how even simple as things like adding airflow, smell, or music can reduce your motion sickness over time. Oops. Then there's a second layer, it's really the bedrock of technical performance. So this is really what we could call temporal predictive fidelity. So that's really the system's ability to really deliver sensory information that is predictable, consistent over time, just like in the real world. Because we really expect a reality that is temporally stable, responds instantaneously, consistently to our actions. This is this second layer here, also quite critical. So comfort really on this level is built on engineering excellence. So it's really a lot about the technical aspect. The user has very little influence here, unfortunately. So basically, content creators and platform developers, they really should push for low latency, high stable refresh rates, tracking low persistence displays, and the developers and content creators can really focus more on maybe optimizing, profiling, and really working with the hardware together. The user, if you're lucky, you can get a better system, or there might be some settings, but you have very limited agency at this level here. Now the third level is really the developer's toolkit. This is really about designing for comfort. We could call it the environmental predictive fidelity. So basically the idea of crafting a world that is coherent, stable, and predictable, that kind of behaves in a manner consistent with what we would expect. Physics, space, object permanence, all these kind of different aspects in there. So this is really more about shared control or partnership in comfort. So the developers provide the tools and the users should be able to choose them. This can be all kinds of different things, like the developer's responsibility is really to implement them and to implement things that make sense. And to implement a robust, accessible toolkit of these kind of different comfort options, like mentioning optic flow, scene complexity, and so on. And the users, well, they need to be able and actually choose and tune and disable, enable, all of these kind of things. So here's just one example how you can do this. We built a VR sickness benchmark. Basically, it's like an infinite figure-8 roller coaster loop. And the idea there was basically to see, like, okay, if we can get you very quickly sick, just like in a roller coaster, would sickness, like within minutes, would sickness also go down that quickly? And we could show exactly that, which means we can actually run within subject motion sickness studies, because we know we've seen that there's pretty much no transfer in there. Just one example there. That brings us to the layer 4. This is really about choosing how you move. This is about locomotion, navigation, these aspects. And we could call this more agential predictive fidelity. So really ensuring that the virtual self-motion is predictable, intuitive, the consequence of your own volitional actions and interactions. So for example, in a leaning-based interface, if I move forward, I expect this to go in this direction and proportional to the amount. So takeaway there, this is really the power of choice. So agency is really about providing the user with useful palette of well-implemented, clearly explained, suitable locomotion options. And then the user has the possibility, should have the possibility to really find the best balance and the best options, maybe switch on the fly as needed, basically. And just as an example, what we tried here is, for example, to see, well, if you give people a bit more embodied locomotion cues, like instead of using control, ask them to lean on a chair or do this kind of stepping motions or physically walk, in that case in a navigational search task, would that actually help to improve performance? And yes, it does. So basically, the more embodied cues you provided, the more cybersickness went down, task difficulty went down, and also completion time went down. So the idea really worked in the sense that even partial-based body cues really help to improve and get some of the benefits of actual walking. All right, now the fifth and final layer is really the layer about the user, their strategies, their cognition. And so where you're really the master of your own experience. But in order to be able to do this, it's really also knowing the different strategies and being aware in the moment and switching to them. So the user is really the agent here. So the ability to be mindful of your own current state, needs, and so on, and then apply the different strategies and options and so on. And in a way, that's most crucial. Like, even if there's some issues here, you can often compensate for that. In the worst case, you have to close your eyes, but they are strategies. They typically negatively affect other aspects here, of course, as well. And, oh, yeah. And the developer's role is really a bit more indirect. It's really to support the user and not punish them for taking care of themselves, taking breaks, all these kind of things. Now, let me give you an example of how that could work. So imagine you're, let's say, SIGGRAPH or a big VR conference. So Alex was trying to prepare her talk, didn't sleep much, is already a bit of a problem. The room is a bit stuffy and noisy, and so on. So there's already big holes in the setup here. Now, let's say she tries to do a demo, but it runs on a laptop that has been running for hours, so thermal throttling, so it has some jitter and basically some glitches and so on. Another hole in that layer as well. And then the company that tries to really show off their VR experience as being super hardcore and high fidelity visuals, so they switch off the comfort options. They don't want to reduce the field of view. So that creates another big issue on that side, or a big hole, if you like. And then she could have the ability to just not do it, or close her eyes, or slow down, but she wants to get a job with that company, so she doesn't want to appear as weak. So she pushes through, and then what happens is basically, if the holes align, that's kind of the ideas of the Swiss cheese model from safety sciences, then when you really have the biggest collapse in user experience. So what do we have here? So ideally, these really are a hierarchical level, a bit similar to, let's say, Maslow's hierarchy of needs. So basically, each one builds on top of each other. In reality, however, there's often some issues, and often they can compensate and defend each other a little bit. And what I try to put in this model is really the predictive fidelity as a unifying framework, basically. And not to have a meta theory, but really to put them into the different layers so it makes sense, kind of. And the main idea is really the prediction error, as you know, and it's really the misalignment between the expectation and the actual perception, and also where exactly these happen. So try to go through this a little bit. So layer 1 really sets the priors and readiness. Layer 2 is really the temporal predictive fidelity. So in simple terms, signals arrive when the brain expects them to do. And if you don't have that, well, then you have a problem. Environmental predictive fidelity is really, okay, does the world behave the way it should and the way you expect it to? Like, is the rest frame actually stable? If not, well, you have a problem. Layer 4 is really about agential predictive fidelity. So the user or the system moves really as the user expects them to. And layer 5 is really about supporting adaptation and regulation and so on. And here's my attempt to map the different theories to the different layers. So of course, sensory conflict on your mismatch theory happens mostly at these levels. Latency, DVP would be here and so on. So you can kind of match the different theories and see where they happen. And so in the end, what we have then is a framework where you have the different layers. And what I thought was really interesting is to see who has agency kind of at what different level here. And then having really this principle of predictive fidelity, which is very similar to the neural mismatch theory, but it's split up into the different parts. So I think there's a little bit more than that. And yeah, that's the idea. I do have a preprint of that, so if you want to look up the slides, you can do this. I'm not sure whether the QR code works right now because my website is a bit broke. Try to stay within 15 minutes so we have a bit of time for discussion.
Okay.
No idea whether I managed to do that.
You excellently stayed within the 15 minutes. So